All right, in our last video, we saw how to get to these rules, or what these rules for logarithms were. We didn't actually prove anything or whatever, but we did look at why they seem to work or how they make sense anyway by looking at some examples. Now what we're going to do is we're going to use these rules to do what probably your homework or your textbook is going to ask you to do, and it's going to ask you to expand and condense these logs. And later on, we're going to use these properties to actually solve equations also. So we're just taking it in baby steps first. We're just going to expand and condense expressions, and then later on we'll use these rules to actually go ahead and solve equations. And that's when it will get real fun, because then that will be the real meaning of logarithms. When we solve exponential equations, we'll know why they actually exist. So let's take a look at this log. What I'm going to do is I'm going to use this first rule that we have here, because we can see that we have things multiplied together inside of a logarithm, just like we have here, okay? This one happens to be base 8. We said earlier it makes no difference what base we use. The rule is the same for all the bases, as long as the base is the same in all the expressions, all right? So the first thing I'm going to do is break them apart into pluses and pluses. In this case, no minuses, because there's no division, but we're going to separate them into sums. So I'm going to rewrite this one as log base 8 of a to the 4th plus log base 8 of b to the 6th plus log base 8 of c. All right. Now I'm almost done, but the last thing that I want to do is look at my other rule. If you take a look at this one, when we have an value raised to a power, we get to stick that exponent in the front. And that's actually going to be my last step in expanding this one. I'm going to move these exponents to the front, and I'm going to write this one as log base 8 of a plus 6 log base 8 of b plus log base 8 of c. Since he doesn't have an exponent, he doesn't get to have a number in front. And this would be expanded. That would be my expanded logarithm. All right, let's do one more, and then we'll do a condense. So let's take a look. I don't know. Log base 4 of a to the 6th b times, I don't know, c to the 3rd. Let's do this one. Ready? All right. Now, which rules am I going to be thinking about? In this case, we see, things are raised to a power, we see things are multiplied, and we see things are divided. So I'm actually going to have to use all three of them for the multiply, the divide, and the raised to a power. And I'm going to do it sort of the way that you would do it if you were solving an equation. I'm going to make sure that I follow, I guess, basically my order of operations. I'm going to think about this one first. So since this is like a grouping symbol, I'm going to take care of this one first. And the division, of course, means subtract. So I'm going to do subtract, but I'm going to put this like this, just so I remember that everything that comes next, I'm going to subtract. Because what I'm going to do in a second is break this one apart using my addition, because we have multiplication here. So we know that we can break this into two separate logs being added together. And I put the parentheses so that I don't make any mistakes, because we actually have to subtract both of those, not just one of them. So my next step is going to be this. Break this one into 2. And there he is. Remember, if you don't have the parentheses here, then you actually have the wrong value. Now I'm going to worry about these exponents. I'm going to bring them down to the front. And if we don't have our parentheses, then it's the wrong value. So I'm going to make sure I put my parentheses. And actually, for me, I would accept this answer. I feel, oh, not this one, because I already brought the 6 down. So you shouldn't have a 6 there after you already brought it down. But I would accept this answer. But some people might like you to get rid of these grouping symbols here, these parentheses. So if that's the case, if that's what your teacher likes, or that's what you like, then you may do that. But that means you have to distribute this negative. So these things, of course, say the same thing. They all say the same thing. But this one would be okay with me, and that one would be okay with me if we were expanding these logarithms. I feel like either one of those was expanded. I'd be happy with either one. All right. Now let's get to the opposite way. Let's condense. You ready? So I'll leave these rules here again. And we'll take one that's already expanded and we'll put it back in condensed form. So let's take a look. I don't know. Log base 4 of x over 2 plus log base 4 of y over 2 plus log base 4 of z over 2. How about this one? So this isn't a great marker, so I'll switch my marker here. Okay, so this one, I'm going from this side and I'm going this way. So we see some pluses, so we know we're going to have some multiplication. And you feel like maybe you see some division here, and so you think maybe it's going to be this one, but it's actually going to be this one, and I'll show you why. Let's take a look. The first thing I'm going to do is write it this way because I think it'll be easier for everybody to see. So everybody knows that dividing by 2 is the same as multiplying by a half. So I'm actually going to think about it this way. And when you look at it this way, now it seems a little clearer that it's actually this one. It's the number in front, and you're going to bring it up here as an exponent. And that's what I'm going to do next. I'm going to bring all of these guys up here. And I'm going to say log base 4 of x to the 1/2 plus. Now, if there were numbers, if there were logs down here, or if it were, this would be different. Let's do this one. So you can see the difference. This would have been one where I would have had to use my division rule. I would have had to use this one. See the difference? We got something divided inside of the log, and this is a variable, and this is a variable, or there are two values. So that would have been one that I would have been thinking about the other one. But this is just this whole log divided by 2, which means we have a number in front, basically. Okay, so do you see the difference? This would be log 4 of y to the 1/2 plus log 4 of z to the 1/2. Now I'm going to take care of these. So I did the things like closest to it first, and now I'm going to combine the terms. So I took care of everything inside each term first, and now I'm going to combine these terms. And how do I do that? Well, I'm going to multiply these expressions together inside one log. So I'm going to have log base 4 of x to the 1/2, y to the 1/2, z to the 1/2. Now, once again, this one I probably would be okay with if you got to there. I might be okay with that one, but we can actually make it a little simpler. We could call all of these to the 1/2. Do you see that? Because that's, one of our rules. You would, when you raise a power to a power, these are all ones and you're raising it to the 1/2. So this one I like much better. This is one I definitely would like to see. I would love that if you got there. And if you're looking in the textbook, or if you're looking at some other people's answers, they may actually have rewritten it this way, because we know that the 1/2 can be the same thing as the square root. So you could see either of these. This is the one I love the most. That's the one I would hope to see on your paper if you were turning it into me. Should we try one more? Okay, let's try one more, and then you can go and practice some of your own. How's that? Let's do this one. Let's do 24 log base 7 of w plus 24 log base 7 of u minus, 5 log base 7 of v. Okay, so we have to take care of the things inside each term first, I just got through saying, and then we'll worry about these, okay? So let's do this stuff first. So I'm going to move the 24s to here. I just picked 24 to be funny, because why not use a big number? I could have used any number. I could have used, 3/9, 4 over 17, negative 200. It doesn't matter what that number is. You're just going to bring it to the, make it the exponent, right? Using this one. So it doesn't matter how big it is. So this is going to be log base 7 of w to the 24th, and plus log base 7 of u to the 24th, and then we have minus, I'm going to move him, 7v to the 5th. So I took care of everything that I could have inside each term, and now I'm going to start combining, and I'm going to combine these two first, because that's, going right to left. That's what I'm going to do. Left to right, that's what I'm going to do. So I'm going to have log base 7 of w to the 24th and u to the 24th. And we just talked about that one. I can actually make these both to the 24th if I want. So I can leave it that way, or I could write it this way. So I did that so that we could see that again, just in case you see it written either way. They're the same thing. Okay. And now let's take care of this division. So now this is one term and I'm subtracting another term. So in other words, I'm dividing these expressions. So it's going to be log 7 of WU all over B to the 5th inside. I'm going to just put this just so you can see it clearly that it's all inside that same log. And again, if I had left it this way, it would have been the same thing. This would have been the same thing. So either one of these I would have been happy with. I like them both. Oh, sorry, that's a 4. This one makes me a little happier. I don't know why, but I just like that one better. I think he looks cuter, so that's probably how I would write it. But either way is fine. So there we have condensed and expanded logs. Now go try some.